So this would be the front page. I'll probably call it page 3 on Canvas. We'll start with problem number 10. So problem number 10 has to be simplified because it's really not written in proper math. You're not supposed to have something with a radical in the denominator. So we've got to find a way to fix this, and the way that we fix this is by multiplying by the big one. And the big one is going to be the conjugate of what's already there. And the conjugate, remember, is the first number stays the same, the second number stays the same, but we change the sign in between. And what that will do for us is it will get rid of the radical symbol. So I'm going to go ahead and multiply this out. This would be 6 plus 3 square root 5 plus 2 square root 5 plus the square root of 5 times the square root of 5, which is the square root of 25, which is just 5. And on the bottom, 2 times 2 is 4. This would be plus 2 square root 5 minus 2 square root 5 minus the square root of 5 times the square root of 5, which is just 5. So what you can notice on this one then is that the positive 2 square root of 5 and the negative 2 square root of 5 cancel. So that's why we multiply by the conjugate, so we can get rid of the radical on the bottom of the fraction. So 4 minus 5 on the bottom would be negative 1. And then this would be 6 plus 5, which is 11, plus 5 square root 5. So it could be written like this, or you could move the negative up with the top and have negative 11 minus 5 square root 5. Those would be the same answers. On the next one, this one has to be simplified because we have an imaginary number in the denominator. So when we have something in the denominator that we don't want, we're going to multiply by the conjugate if it's a binomial. So on this one, I'm going to multiply by the big one. And the big one, I'm going to do the conjugate of the denominator. So I'm going to do 2 minus 4i, 2 minus 4i. Because remember, when the numerator and the denominator are the same, we've really just multiplied by the number 1. So let's multiply this out then. I'm going to have 6 minus 12i plus 2i plus 4i squared, minus 4i squared, over 2 times 2 is 4. This would be minus 8i plus 8i, so they're going to cancel, and then minus 16i squared. As a reminder, I squared is the same thing as negative 1, so really it just changes the sign of this last number to be positive 4. So on the top I have 6 and positive 4, which is 10. And then here I have minus 10i over, this turns to negative 1, which turns this into plus 16, so it would be a 20. Now the thing about this is all of these numbers are divisible by 10, so we can factor a 10 out of them. And the 10 will cancel. So the answer is just 1 minus I all over 2. The last one is just a reminder here about how to multiply imaginary numbers. And we've been doing that in this previous problem. 2 times 5 is 10 minus 14i plus 20i minus 28i squared. And a reminder, this is negative 1. So that makes this thing a plus 28. So 10 plus 28 is 38. Negative 14i and positive 20i is plus 6i. All right, let's move down to this last thing. And this is what we just learned in our last unit. Notice that every one of these problems, this is not just a single fraction and a single fraction, so I can't cross multiply here. What I'm going to have to do is see if I can get a common denominator. And this factors to x plus 1. I'm going to change this to plus and negative 2. This is x times x plus 2, and that's just x plus 2. So I'm going to get rid of the fraction by multiplying both sides of this fraction by the least common multiple, which is the common denominator. So I'm going to multiply times x and x plus 2. Same thing over here. Whatever I multiply times one side, I have to do to the other. So on the left side now, the x plus 2 and the x plus 2 will cancel. So when I distribute here, I just have x times 5x. When I distribute here, the x cancels with the x, and the x plus 2 cancels with the x plus 2, so we just have minus 2. On the right side, when I distribute, the x plus 2 and the x plus 2 cancel, so I'm left with 9x. And this is a much nicer looking equation than what I had. So this gives me 5x squared minus 2 equals 9x. So 5x squared minus 9x minus 2 equals 0. I'll see if that factors. So 5x and x, and 2, 1, I want it to be minus 10 and plus 1. So x would be negative 1/5, or x would be 2. Both of those answers would make that statement true. Look at this next one. So I want to get, first thing, I'm going to change this subtraction to add negative 3. And then instead of 1, I want to make this something that's my least common multiple. So I can change that 1 to whatever I want. This goes to x plus 7, x minus 6. So I want to multiply both sides of this equation, and I don't really have room to write it over here, but I'm going to multiply both sides of this equation times x plus 7 and x minus 6. So I've got to multiply this entire thing times 1. And then I'm going to multiply this entire thing times negative 3, but the x plus 7's cancel, so I just have minus 3 times x minus 6. And then when I multiply this times this side, everything cancels, so I just get 3x. So when I multiply that out, I get x squared plus x minus 42 minus 3x plus 18 equals 3x. So let's see here, x squared. Positive x and negative 3x is negative 2x. Move the 3 over, so it'd be negative 5x. And negative 42 and 18 would be negative 24. And now I want to see if this factors. This factors to x minus 8 and x plus 3. So x equals 8 or x equals negative 3. 2 answers. Okay, number 12, I want to solve. So since it starts off as a logarithm, the way that I'm going to solve it is by turning it into an exponent. So since this is base 2, I'm going to move it to the other side so that I have x plus 1 over 5 equals 2 to the third. And 2 to the third is 8. So let's see here, I'm going to have to move over here. So I have x plus 1 over 5 equals 8. Multiply both sides times 5, so I get x plus 1 equals 40, so x equals 39. The next one starts off as an exponent, so the way that I'm going to have to solve it is by logging both sides. I know that 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, so it's going to be 2 point something. So I'm going to start off by logging both sides. And now that I've logged, this x can move to the front and become the coefficient. So I have x log 3 equals log 15. And then to get x by itself, I'm going to divide both sides by log 3. So I get x equals, and then when I punch that into my calculator, I would have log 15 divided by log 3. And you get 2.46, and we knew it was going to be 2 point something. So that answer makes sense. All right, we haven't done long division in a while, so this is a good review. I want to divide x cubed plus 10x squared plus 29x plus 12 by x plus 4. Remember that sometimes not every one of these terms is represented. So let's say the x squared term was missing. I'd have to remember to put a 0 here. All right, I want to look and see what would I multiply times x to get x cubed. And that would be x squared. So I'm going to put an x squared above the 10x squared. And now I'm going to distribute. X squared times x is x cubed. And x squared times 4 is 4x squared. But with long division now, we're going to subtract. So these cancel. And 10x squared minus 4x squared is 6x squared. Excuse me. Now I want to decide, what do I multiply times x to get 6x squared? And that is 6x. 6x times x is 6x squared. And 6x times 4 is 24x. And then I'm going to subtract. And what should happen when I subtract is these should cancel. 29 minus 24 is 25x. Bring down the 12. Now I want to see, what would I multiply times x to get 25x, and that would be 25. 25x plus 100. And I'm going to subtract. 12 minus 100 is negative 88. So I would have a remainder this time of plus negative 88 over x plus 4. Or I could write minus 88 over x plus 4. All right, the last one on this page, and this is kind of a lengthy one. I have 3 unknowns, 3 variables. So I want to try to use elimination or substitution. And I'm going to use elimination. I'm going to start by, I notice that these are 8 and these are 8. So I think on this particular problem, I'm going to try to eliminate the y's first. So since this is positive 8 and this is negative 8, I can eliminate by adding these first 2 equations. So 7x plus 5x is 12x. Positive 8y and negative 8y is 0y. Negative 8z and positive 5z is negative 3z. And negative 1 and negative 8 equals negative 9. Notice I eliminated the y's. I want to eliminate the y's here, but this time, since they're the same sign, I'm going to multiply everything on the bottom by negative so that it cancels. So positive 5 and negative 4x is x. Negative 8y, positive 8y cancels. Positive 5z, negative 5z, this is nice. This one cancels too. In negative 8 and positive 9 is 1. So this one worked out really good because typically I would have to eliminate again, but this one just happened to work out that I got x on the first try. So I'm going to go now that I know x and substitute it in here. So 12 times 1 minus 3z equals negative 9. 12 minus 3z equals negative 9. Negative 3z equals negative 21, so z equals 7. And now that I know that, now that I know that z equals 7, I can go substitute it into any equation I want. I think I'll just pick the middle one. So 5 times 1 minus 8y plus 5 times 7 equals negative 8. 5 minus 8y plus 35 equals negative 8. 5 and 35 is 40. Subtract 40 from both sides. So y equals 6.